Hello everyone. Welcome to my channel BBTechHub. So today is the last layer what I am going to discuss over here. That is OSI reference models physical layer. So last 7 to 8 days I am dealing with this OSI layer, and every layer I discussed in detail about that. And today I am completing this OSI layer with the physical layer. So far, I think you have developed a concept ki how data communication is taking place when we are the human being interacting with the system, whether it is a computer, laptop, and mobile. We are interacting with the internet. What happens? How data is going through? Okay. So in this physical layer, this is the actual layer what we people can visualize. This is the we call this is the you can say it is the bottom layer, of course, bottom layer, but we said this is the first layer of OSI model. This is the first layer. Is it clear? And this is the layer where two devices are actually physically connected with each other. This is my physical connectivity. Is it clear? And in this layer, what happened? No header is added, my dear. Physical layer receives the data from the data link layer. So this is the data link layer, and if I say this is the physical layer does not need any header. Why? Because devices are directly connected through this physical layer. Is it clear? And at the receiving end, physical layer receiving the data through the physical connectivity, and then it is transferring the data to the data link layer. So this is very important layer. In this layer, what happened? Whoever the network designer, here the device connectivity happens. So we call this as the first layer of OSI model, and in this layer actually define what will be the electrical mechanical specifications. That means what type of cable connectors will be used. If you think the first function of this layer, that is, it will establish the connection, maintain the connection, and terminating the connection between the devices, and 100% it is physically. There is no concept of logical connectivity over here. What type of cable I am using? So we called it is the characteristics media. What will be the bandwidth, whether it is 1 Gbps, 1 Mbps, 100 Mbps, 2 Mbps, what will be the bandwidth? What will be the segment length? That means what will be the maximum length of a cable which can give me the fullest of signal? What will be the attenuation? What will be the crosstalk of the cable? In this layer only we are dealing. On the basis of this characteristics of media, an organization choose the cabling system. What will be the signal coding? What is this? Actually, my dear, what happens? We are saying the PDU of the data physical layer is the bits or signal. Is it clear? The moment it is receiving the frame, the physical layer just break down the frames in zeros and ones. We call this is the binary bits. So, but in real, when this data is transferring to through the cable, it becomes an electrical signals. It becomes a voltage level. Is it clear? So the moment it is transferring the data through the cable, and this 01 becomes the voltage level, this concept is called as signal encoding. There are two types of voltage levels we consider in this data communication system. Either one's a positive voltage level, another is the negative voltage level. Okay. So here it has been decided, so when a data or 0 and 1 is converting to the signal, whether it is using the positive voltage levels or whether it is using the negative voltage levels. Of course, I told you the PDU is the bits or signals. Is it clear? And when the two devices are actually communicating through the physical media, then here is the transmission of raw bits in the form of current. So here is the word is common. We call it as a signal. So do you know what is signal? Signal is nothing but the electric. This is the current, or you can say the voltage, or you can say it is a radio wave, which carries the data and information from one device to another device. Is it clear? This is called the signal. If I say electrical signal, then it is electric current. If we say this is a radio signal, that is the radio, it is also a wireless signal, but all are carrying the data in the different form. Is it? Now, in this layer, the transmission mode is also decided. What is the transmission mode? In networking videos, I told you, transmission mode is, that is mean the direction of signal flow. It may be simplex, half duplex, full duplex. Simplex means one-way communication, which is highly prohibited in the data communication system. Simplex is used like a voice communication system, like your TV, radio. In simplex, there is a no acknowledgement from the receiver. Is it clear? So whenever there is no acknowledgement from the receiver, so there is no use of such type of communication technology in the data communication system. It is highly seldom in the data communication system. Then what type of transmission mode or data communication system is using? That is half duplex and full duplex. Both are providing both way of communication, but in case of half duplex, it is one communication at a time. That means either sending or receiving. But in case of the full duplex, there is a no problem. Both way communication can take place simultaneously. That's it is called as a full duplex. Now, physical layer also responsible for line configuration. Line configuration is nothing but how devices are connected with line or cable. In the networking, line means we define the cable, physical cable. The physical cable, how the devices are connected defines the line configuration. It may be multi-point or it may be the point-to-point. In case of multi-point line configuration, multi-point line, of what happens? Single bandwidth shared by multiple devices. This is a shared media, and you think there is a shared media, multiple devices, will you get the performance, good performance? No, you cannot. So what is that point to point? Point to point is saying, don't worry, there is a dedicated, 100% dedicated link between two devices, and no other device can use it at a time. Is it clear? So all these physical level of connectivity, technologies, concept, protocols, all are coming in this physical layer. This is the layer where actual the network is laid down, where actual we do the hands-on, where we are configuring our network. Is it clear? And this physically is responsible for nothing but the transferring data from one device to another device. So now I'm going for a conclusion of this OSI reference model. We have seen there are 7 layers. Application is the 7th layer and physical is my first layer. Every layer is adding a header except the physical layer, because physical layer is connected with each other directly. And there is another exception, that is data link layer is adding a header as well as a trailer for the error check. Is it clear? And we have seen what are the PDUs. We have seen application, presentation, and session. Data is called as data or message. If I go to the session layer in if we go to the transport layer, it is called as a segment. In the network, data is called as packet. In the data link layer, data is called as frame, and in the physical layer, data is called as bits or signal. Is it? If you go to the physical layer, what device we are using? That is called the hub, or previously before hub, the device was repeater. If you go to the data link layer, we are using switch. Previously we used bridge. If you go to the network layer, what happens? That is nothing but my router. Is it clear? And in the networking layer, we are dealing with the IP address. Devices are identified in a network using IP address. In the data link layer, devices are identified using the MAC address. Okay. In the physical layer, there is no address scheme we are using. And if you go to the transport layer, we are using the port address to identify what? The port address is identify each application running over there. And in this OSI, we say network layer is responsible for end-to-end delivery. That is, it is responsible for one IP to another IP connectivity, where is the transport layer is responsible for process to process delivery. That means under single IP, multiple processes are there. Maybe network layer will take the data from one IP to another IP, but transport layer will deliver the particular application, the particular data. Is it clear? Every application is getting the particular application data. For who is this responsible? Transport layer. So we call transport layer is responsible for process to process delivery, and network layer is responsible for end-to-end delivery. So this is the concept laid down by OSI, and every manufacturer or the vendors in the network industry has to follow these guidelines. In these 7 layers, all are the guidelines so far I have discussed. So on the basis of these guidelines, today's this internet has been formed, where every people can communicate with each other. This is nothing but an open communication. So I think you people enjoyed all these layers. Again, I'm saying, if you have a query, you put questions in the comment box. I will answer you within 24 hours. Okay, fine. So thank you. In the next video, we will go for the next topic of CCNA. Wait and watch. Thank you.